Hey guys, welcome to the 79th C programming tutorial, and in this tutorial we're going to be talking about the generic pointer, otherwise known as the void star. And the generic pointer can point to anything. It can store the address of an integer, a float, a fraction struct, a character, or a long. It can store the address of anything that you want it to. So right here I already have some code written out. I have an integer variable called I set equal to 7, a float called f set equal to 3.9, and a fraction called fract, which is set equal to 5/6. And I'm not sure if you've ever seen me use this notation before, but basically what this is going to do right here is it's going to set the first field inside of the struct equal to the first element inside of this array. So 5 will be the numerator and 6 will become the denominator. And you can use this with any struct you want to, not just ones that only have integers or ones that only have strings. So if there was another field inside of this struct right here, let's say there's another field called name or something, then what we could do right here is just say like Adam, like that. So now what would happen is the numerator would be 5, the denominator would be 6, and then this third field right here called name would just be Adam. Alright, but we obviously don't want to have a name for our fraction, so let's go ahead and delete that. So now let's say that we wanted to create a pointer that stores the address of I right here. Well, since I is an integer, what we're going to have to do is create an integer pointer. So we're going to say int pointer IP for integer pointer, and then I'll just set it equal to the address of I. If I wanted to create a pointer that stores the address of our float variable right here called f, well, I'll have to create a float pointer since f is a float. So I'll have to say float pointer fp for float pointer and just set it equal to the address of f. And if I wanted to create a pointer that stores the address of fract, then since fract is a fraction, I'll have to create a fraction pointer that stores the address of fract. So I'll just say fract p for fract pointer and set it equal to the address of fract. But let's say that we wanted to create a generic pointer that could store the address of anything. So it could store the address of I, f, fract, or even the address of our float pointer. So in order to do that, in order to create any generic pointer, you're just going to write out void and then an asterisk and then just the name of your pointer. So I'll just call it my pointer. And we can set it equal to the address of anything we want to. We could set it equal to the address of I. And if I build this, we won't get any errors. We get some warnings, but 0 errors. And if I set it equal to the address of f and build it, that's fine as well. Set it equal to the address of fract, that's fine. And if I wanted to, I could even set it equal to the address of a float pointer. So the address of fp, build it, and that works fine as well. But we'll just leave it as pointing to I. So I build that, and again, 0 errors. Alright. So let's say that I wanted to go down here and just print out the integer that was pointed to by the void star called my pointer right here. So I'll just go down here and say printf mod I, since we're printing out an integer, and then all I'll do is just dereference our void star called my pointer. So dereference my pointer. So all that we're going to do right here is we're just going to go to the address that is inside of this void star. So we're going to go to the address of I and then just read the integer there and print it out onto the screen. So let's just run this, and we get an error. And that's because it says we cannot dereference a void star. So, and we're getting an error here because you cannot dereference a void star. And let's talk a little bit about why you cannot. It makes sense. So let's just go to this picture right here in Paint. So right here we have our integer pointer called IP, and it's just storing the address of I, and it obviously just points to I right here. And then we have our float pointer called FP, which stores the address of the float, and then we have fract P, which just stores the address of our fraction. And then down here we have our void star called my pointer, which just stores the address of I. Well, whenever we dereference an integer pointer, it just goes to the address that's stored inside of that integer pointer and then just reads 4 bytes, since an integer is 4 bytes in size. Same thing with a float. Since a float is 4 bytes in size, it knows exactly how much memory to grab at that address. So it goes to the address that is stored inside of this float pointer and then just reads 4 bytes, since the size of a float is 4 bytes. Now with a fraction down here, it goes to the address that is stored inside of fract p, and then it just reads 8 bytes. So if you ever to dereference a fract p right here, it would just go to the address that is stored inside of this fraction and read 8 bytes, since the size of a fraction is 8. But with this void star right here, it could point to anything. It could be pointing to a character, a fraction, or some huge struct that's 128 bytes in size. We have no idea. So when it goes to the address that's stored in it, it has no idea how much memory to grab when someone's trying to dereference it. That's why you cannot dereference a void star. So let's say that we wanted to go back here and actually print out the integer that is at the address stored in my pointer right here. Well, right now we know that it's pointing to an integer, so what we'll have to do is just cast my pointer as an integer pointer. So we're just casting our void star as an integer pointer, and then we'll just dereference that as though it's an integer pointer. So now what it's going to do, since we casted this, it's going to think that my pointer is an integer pointer. So now when we go to the address right here, since it's an integer pointer, it knows how many bytes to read. We casted it as an integer pointer, and then we just decided to dereference that. So we go to the address, it thinks it's an integer pointer, and it knows how many bytes to read now since it has a type. So now when we run this, it'll work fine. And yeah, we get 7. And if we wanted to, we could cast this as a float pointer and then dereference that. So now what it's going to do back in Paint right here, it's going to think that my pointer is a float pointer. So now when we dereference it, it's going to go to the address stored in my pointer, and it's going to read these 4 bytes right here as though they're a float. So when we run this, I have no idea what we're going to get out onto the screen. We could get 10 million or we could get 0. No idea. We run this and, oh, I gotta change this so it's printing out a float. Run this and we get 0. So what it did is it just went to the address that was stored inside of my pointer right here that was a void star. It treated that as though it was a float pointer, so when we dereferenced it, it read 4 bytes there and interpreted those 4 bytes as though it was a float. But actually what was at that address was an integer, so it interpreted those 4 bytes as 0. So that's it for this tutorial on the generic pointer. In the next tutorial, you'll see actually why the generic pointer is useful. Alright, so see you guys.